Gravity acceleration, something that could be assumed as physics of nature. When you have a ball on the rooftop, probably you heard that example a lot, and you drop it down, assuming there is no strong winds or the wind resistance is, or the wind's influence on the ball is minor, then the ball would be doing a free falling. That free falling, until it reaches the ground, it will be gaining acceleration. It will be accelerated towards the earth. And that is called gravity acceleration. Scientists did the homework and measured what is the gravity acceleration without the effect of any kind of resistance. That will we learn as we're moving forward. So how to use the gravity acceleration? You can see somebody holding a ball on a certain height, delta dy in this case. So the ball will be dropped to the floor by gravity. As you know, it's a natural phenomena. The initial velocity over here was 0 because he was holding the ball in his hand. Now he dropped the ball will start to accelerate. It will accelerate until it hit the ground at a certain speed. Acceleration here is called gravity acceleration, which can be rounded to 9.81 meters per second square, pointing downward. If you have an object that is free falling, there's no force into it, there's no initial speed given to it, then that is an object that is free falling. So always you plug in an acceleration in any problem similar to this as 9.81 meters per second. So you could be stumbled into a problem, then you'll be saying, okay, I'm missing acceleration, I'm missing final velocity, and so and so I can't solve it with any of the equations of motion. Well, you can, because you have the acceleration in most cases. That would be the trick. Example. So a driver throws a smooth round rock straight down with initial speed of 4 meters per second, v initial here. If the rock takes 50 seconds to land in water, how high is the cliff? So it's given for you, v initial 4 meters per second, time delta t 2.5 seconds, and you have acceleration as 9.81 meters per second down, which is a plus value in this case. What he needs, the delta d. So third equation of motion, v initial plus multiplied by delta t plus 1 over 2 multiplied by a by delta t squared will give you 4 by 2.5 plus 1 over 2 by the acceleration by gravity 9.81 by 2.5 squared as delta t. That would give you 10 plus 30.7. That would give you 40.7 meters displacement.